Supplementary, my dear Watson, supplementary. If the sum of their measures is 180 degrees. So let's just say, I like how one person put it. They said, let's let X be the smaller angle. You know one is smaller, right? And we can determine which one is going to be the smaller and which one can be the larger one. So, if the two angles are supplementary, if their sum of the measures is 180. Who am I going to talk to? Micah. What would that first equation be, do you think? From this statement. Yeah, 180 equals X plus Y. How many of you had that for a first equation? Okay, yeah, that one's not so bad. Then it says, if one angle's measure is 90 more than twice the measure of the other. So according to this, one angle is 90 more than twice the other. And this has the word is. What does the word is often imply mathematically? Equals, right? So one angle's measure is 90 more than twice the measure of the other. Based on what I have up here, what would you write down? 90 plus 2x is equal to y. One angle's measure, y, is 90 more than twice the other. And we know that y is the larger one, so 2 times x plus 90 should give us that equal amount. What do you think of that? Anybody have that or something similar, like y equals 2x plus 90? Okay, or maybe you had the x and y reversed, doesn't matter, because we don't know yet. All right, so how would I solve this? You can do substitution here, yes. Y is 2x plus 90, so substitute this in place of y. So 180 is equal to x plus 90 plus 2x. And here, what would you do? Combine like terms. X plus 2x is 3x plus 90. Subtract 90 from both sides. Am I going too fast? Yes. Am I? Okay. Down. Do you see where I substituted it in for y? So 180 equals x plus 90 plus 2x. I'm simplifying the x and the 2x to be 3x plus 90. Subtract 90 so we can try to isolate the x. 3x is equal to 90 itself. So divide by 3, and x is equal to 30. So the smaller angle is 30, and substitute that probably in whichever one seems simpler, which for me would be the top one. 180 equals x, which is 30 plus y. Subtract 30. So y is equal to 150. What are the measures of the angle? X is equal to 30 degrees. Yes, you should label it. And y is equal to 150 degrees. Any questions on that? Okay. Now, this next part. Did I need to go back? This next part, this has to do with the second half of the homework for, what is this, Module 5.1? which some of you were like struggling with, I believe, maybe. So we're going to talk about it a little bit. Consider the equation 5x minus 2y equals 3. If possible, find a second linear equation to create a system of equations that has one solution. So when you have two lines, how many different ways can we have solutions? We can have how many solutions? If you have two lines in a plane, how many different solutions, not how many different solutions, how many different, what do I want to say, possible solutions could we have, depending upon how the lines are graphed? We could have one solution. We could have no solutions. And what kind of lines would those be? That would be parallel lines. One solution would be what kind of lines? Intersecting. And we could also have, what is it? Infinite many solutions, and that would be overlapping lines. I never remember the word overlapping. I always say line on top of itself, and it sounds so kiddish. I don't think she was laughing at my joke. One solution, no solution, or infinitely many lines. If I have one solution, well, let's go back to no solutions. What has to be the same if we have no solutions? Okay, they have to have the same slope, right? And what? Something else. Same slope and think about it. If you have two lines that go like this, they're parallel. They have to have the same slope, but they have to have different y-intercepts. This might be important for you a little bit later. I think, is this in your book at all?
Yeah.
On what page?
44.
Oh yeah, page 44. Haha, right up there. What about infinitely many solutions in overlapping lines? They are going to have what? Talk to me about their slope and intercept. Same what? Same y-intercept and same slope. So what about the one solution? If they're intersecting lines, I think they could have the same y-intercepts. I think so. So they would have different slopes, period. And then they might have different y-intercepts or they might have same. So one solution, maybe you try to get this into y equals mx plus b form. And then you come up with a second equation which has, for one solution, a different slope. Because if you have a line anywhere, it extends throughout the whole plane, right? As long as it's not a parallel line or infinite solutions overlapping line, it's got to cross that line somewhere, right? Does that make sense? Let's talk about two solutions. Think about lines. Okay? Remember, these are extended out. So if I look at these lines, is there any way they're going to intersect at exactly two places? No, it's either got to be overlapping, intersecting, or parallel. So is that possible to have exactly two solutions? Not for linear. No. So that one is not possible. Okay. One solution, get this first equation in y equals mx plus b, and then make up any other different kind of line. As long as it has a different slope, you should be okay. 44, consider that same equation. How would I find a second linear equation to create a system of equations that has no solution? What would it have to have again? Second equation would have to have the same slope, but different y-intercepts. Okay, hopefully you can figure out that, an equation that works for that, and infinitely many solutions. The second equation would have the same slope and the same y-intercept. But we don't want it to look exactly like it is. In other words, if I say y equals 3x plus 1, I don't want you to write for the second one, y equals 3x plus 1. That has the same slope. That has the same y-intercept. What could you do to that equation to get you a similar equation that has the same slope and intercept? What? Change the what? The 1. No, not for infinitely many.
Oh, infinitely many?
I'm sorry, I couldn't hear you. Somebody was talking. Daniel, I'm trying to listen.
Are we trying to change around the equations so they're not the same?
Yes.
Oh, so like.
Well, not even change it around. But what could I do? What could I do to this second equation? Because I don't want it to be exactly the same.
Make the y like switch them.
No? What do you mean negative?
Like, I don't know, I'm kind of just spitballing.
Multiply by what? Yeah, you can multiply by -1. You can multiply by 3. Just to rearrange things? Yeah, I'd rather it be something like multiply by -1 or multiply by 3. Okay, multiply by -2. Okay? Because, no, we're not solving. We're just trying to find a second equation that works. Okay? So if you multiply an equation, everything in it by the same number, you should get a different equation. And when you simplify it, you would get the same slope and the same y-intercept. Okay? All right. Hopefully that helps you in the second part of the information. So now you should be able to go on to topic 5, homework number 2. Okay, so you have 2 homeworks now. Homework 5.1 and homework 5.2. Did you grab your phone too on the corner of my desk? All right. I will be here tonight from 2:30 to 3:15. Only 3:15 because I need to go to Avon for a 4 o'clock appointment. All right. So, homework's 5.1, homework 5.2. I will be sending out progress reports very soon, like probably tonight. Okay?